For our next example, we're going to be solving an application involving the Pythagorean theorem. Number 30 states, a portion of a roof truss is given in the figure. The triangle on the left is configured such that the longer leg is 7 feet longer than the shorter leg. That's this darker shaded right triangle. You see the short leg is x, the long leg is x plus 7. And it says the hypotenuse is 1 foot more than twice the shorter leg. So for part A, we're going to find the lengths of the sides of the triangle on the left, the darker shaded one. Let's zoom in on that for right now and let's figure it out. So for part A, and in these Pythagorean theorem problems, we are going to use the Pythagorean theorem that states that the sum of the square of the two legs in any right triangle is equal to the square of the hypotenuse. Or in English, that would be a squared plus b squared equals c squared. Recall that the hypotenuse is always the side that is opposite the right angle. It's going to be the longest side in a right triangle. So on part A, when we, let's let our shorter leg be the x, and we will let our b be x plus 7, and our hypotenuse is going to be the 2x plus 1. When we plug those quantities into our Pythagorean theorem, we get that a squared, which is the x, plus the b squared, now we're going to have to say quantity, x plus 7 squared, is equal to the hypotenuse. That was the 2x plus 1 squared. There's a squared plus b squared equals c squared. Now it's a matter of simplifying this. And so when we square the x, that's just simply x squared. Here for the quantity x plus 7 squared, we're going to need to expand that out and FOIL. You can't just square the x and square the 7. That's not going to end up being x squared plus 49. That will mess up, okay? Same thing on the right-hand side. We're going to expand the 2x plus 1 and FOIL. By expanding those, that's what that exponent of 2 means to do. Multiply it by itself 2 times. Bring down the x squared, then let's FOIL. X plus 7 times x plus 7. The first times the first is x squared. The outer times the outer is 7x. When I combine that with the inner times inner of another 7x, that gives me 14x. And then last times last, 7 times 7 is 49. We're going to FOIL out over there on the right-hand side as well. Now when I multiply first times first, 2x times 2x is 4x squared. The outer times the outer is 2x. When I combine that with inner times inner of another 2x, that is a total of 4x. And then last times last is 1. Now we have kind of a mess, but I do see that we have a quadratic, and so our first step is to get everything on one side equals 0. Now this is actually going to be 2x squared, and so I'm going to subtract that 2x squared from both sides of the equation so that I'll gather up everything that has an x squared on the right hand side and have a positive coefficient here. 4x squared minus 2x squared gives us 2x squared. Alright, let's gather up the x terms by subtracting 14x from both sides. Alright, and that will give us a negative 10x. And then when I subtract 49 from both sides, 1 minus 49 is a negative 48. Now, all the rest of this stuff falls out on the left-hand side, leaving me with 0. So we're ready to solve this equation. And right off the bat, I see everything is divisible by 2. Let's do that. Okay? If we would go through and divide everything through by 2, our equation is now 0 divided by 2 is 0. 2x squared divided by 2 is just x squared. We'll have a minus 5x and then minus 24. Here we are going to factor. I think that'd be the easiest way. You could use quadratic formula to solve this quadratic equation. If a is 1, b is a negative 5, and c is a negative 24. But I think the most efficient way to solve this quadratic equation is to unfoil this. Now the two numbers that multiply to give me negative 24 but combined to give me a negative 5 are the negative 8 and the positive 3. If you want to pause the video now and mentally FOIL that out, you sure can. We have a factor times a factor equals 0. When we take each of these factors and set those equal to 0 to solve for x. Oh, I went ahead and did that one. Okay, add 8 to both sides here, and you get x is equal to 8. And x plus 3 equals 0. When you subtract 3 from both sides, I didn't write that step down, but there it is. X is equal to a negative 3. Now, if we're talking about the length of a side of a triangle, would it make sense for this x value over here to be a negative 3? No way. I don't think so. All right? And so I'm going to take that possibility out. Let me go ahead and clean up the rest of this while I'm at it too. Okay? I'm going to cross out the solution to the quadratic equation of x equals negative 3 because it doesn't make sense for my application problem. The x equals 8 actually makes sense for my application problem. So back over here on my diagram, if I let x be equal to 8, that's the length of the shortest leg. If x is 8, the longer leg here is now 15. Let me put a little circle around that. And if x is 8, 2 times 8 is 16 plus 1. The hypotenuse over here is 17. And so the directions said to find the lengths of the sides of the triangle on the left. We just did that, okay? I think we'll sum up our information right up here. This is an 8, 15, 17 right triangle. All right. And did they say anything about the units up here? Oh, feet, okay? So we should probably say it's 8 feet, 15 feet, and 17 feet. Just to make sure that we label our quantities in our application problem appropriately. Now in part B, it says to find the lengths of the sides of the triangle on the right. That is this lighter shaded one. Okay, now what we know here is that this leg is 9 feet, okay, and we know opposite the right angle is the hypotenuse. Hey, this didn't change any, okay, the hypotenuse is still 15, and so let's see, if I come down here and I say for part B, okay, I've got a leg of 9 feet that was given. And I know that my hypotenuse is, I found that in part A, to be 15 feet. I just need to use my Pythagorean theorem again to find the length of the other leg. Okay? I'm going to scroll just a little bit here. And so for part B, remember your Pythagorean theorem is a squared plus b squared equals c squared. And so I'm going to use 9 for either A or B. It doesn't matter which one you use, so I'll just use it for A. So now I have 9 squared plus my unknown leg length squared is equal to the hypotenuse squared. Now, when I square the 9, that is 81. So 81 plus B squared equals 15 squared. Crunch that in on your calculator, it's 225. Here I'm going to subtract 81 from both sides because now it's just a matter of using just a little bit of algebra to solve for the unknown leg of B. I'm going to extend the page here. There we go. Okay. So I've got B squared is equal to 225 minus 81, and that is 144. Now, when I use my square root property to solve for B, once you write the square root property for B, you normally don't want to forget your plus or minus symbol, true? But here we're talking about the length of a leg. That's why I'm going to choose the positive to say that B is positive square root of 144, which is 12 feet. So my answer on part B of this question, okay, is to say the triangle on the right has a leg of 9 feet. We just found it has another leg of 12 feet and a hypotenuse of 15 feet.